Thank you, Amber. Looks like I'm being recorded now, so we're good to go. Thank you everyone for showing up. And thank you very much for that introduction. So really, what I want to do here first, I want to just give you a little bit of information in terms of what I'm going to be talking about, so you know what to expect. I want to talk a little bit about my background because I think it's an interesting path that my career has taken, and I just know being back when I had hair a long time ago, sitting in on sessions like this, listening to people talk, getting some advice, getting some thoughts about what's the next step, how to kind of approach careers and interviews, I thought would have been really helpful. And so I'm going to talk a little bit about that. So I hope you don't mind. And then I want to talk about you as students, as postdocs. What are some career opportunities that you have? And I think you have a lot more than you might realize out there. It's just how you package yourself and how you market yourself. And then what I want to do is I'm going to talk a little bit about head blight, and from a practical sense, what what do we do? What are the factors that go into scouting, staging, identifying the disease, working with growers, those sorts of things. So I'm just going to give you kind of a holistic picture from the field, what some of the lab work and maybe some of the other things you're doing from a research standpoint, how those might connect to each other. Okay, and then think about how what you're doing might actually connect to that sort of situation. I think that's really important. So this is my little timeline here. I did some fancy animations. So this is my story, right? I was born a long time ago, and as you can see, I had a nice full head of chestnut brown wavy hair, and I haven't changed a bit, right? I look exactly the same now. But I grew up in Wisconsin. I have a bachelor's degree in ecology and organismal biology from the University of Wisconsin Oshkosh. Did a lot of work with mycorrhiza and mycology back then. And then I earned my doctorate at the Ohio State University in plant pathology. And in my project in plant pathology, I actually was working on tree physiology, chemical ecology, and mycorrhizal fungi. It was really kind of an out of the box project. It was kind of an outlier in the department in terms of being one of the people who didn't necessarily focus on controlling a disease or looking at resistance in a plant or anything like that. I was kind of doing some more ecological type work. And then after that, I went to do a postdoc at Indiana University. And there I worked with biofuels, and I was looking at endophytes for promoting growth of biofuels like switchgrass. And I was also looking at biological controls of forest understory weeds. Microstygium faminium was a big one. And I also managed a biogeochemistry lab when I was there. After that, I went to Purdue, and Purdue, actually kind of got into more of the applied work. This is what really got me more into the wanting to interact more with growers, wanting to be more on the field type aspects of research, right? So I was doing vegetable pathology there. And then I got my first real job, right? I went out to the East Coast FMC. I led the research team there. So we were looking at discovering new technologies, biocontrols, growth stimulants, and coming up with ways to test those. And then, as Amber said, I was at the University of Delaware, and that's when I really started to get involved in field crops. So up until this point, my knowledge of wheat, my knowledge of head blight was very minimal. I always joke, when I was at Ohio State, Pierce Paul was a postdoc, and he would give these talks, and he would always mention Don. And I'd always kind of joke around with my friends in the background and say, "Who's Don?" Right? I didn't understand. I didn't understand really what was going on. I probably wasn't paying attention. That was probably my problem. But so I ended up having to learn everything. And if it wasn't for people like Arv Grabowskis and Bob Mulrooney, Eric Stromberg, Don Hirschman, those who I learned about wheat from, and I really loved it, and still do love working with wheat quite a bit. Then I moved back to the Midwest, being closer to home, the University of Illinois, working specifically on field crops there again. And then about 4 years ago, I left for my current role at GROWMARK FS. So I like to say the nice thing about my position is I support people. I don't support products. So I have no sales goals. I don't try to, promote a specific product or anything like that. I train our crop specialists. I go and troubleshoot. I'm basically uh, an extension plant pathologist and entomologist that gets to work with all sorts of people from across the US and Canada. So it's a really nice position. So one of the things I want you to think about as you're going through with your careers is what are you actually getting from graduate school and your postdoctoral experiences. I mentioned I had a lot of experiences in my career, and here I am speaking about head scab. Right, I would have never thought when I was at Indiana that I would be speaking to anyone about head scab. I really didn't know what it was. So think about what it is you're getting. You're getting a set of skills. You may be using those skills in a particular area, but really what are you learning? They're tools, right? That's what you have available in your toolbox. Think about at home. If you've got a toolbox with you and then you keep it in the garage, does that mean you're only going to use that toolbox to fix things in the garage? No, you're going to pick it up. You're going to carry it where you need it, where you can utilize it, and you're going to fix whatever needs fixing. And that's how you got to kind of think about what you're getting out of your experiences in graduate school and your postdocs. It's not that you're an expert at working with vomitoxin in head scab. That may be what you're focusing on, but what are the tools you're using and how might that be applicable to a career where you're looking at different systems or different aspects of wheat production or something like that. You're also building relationships, connections. Those are extremely important, especially when you're younger and people are still getting to know you and you're getting experience. And with experience comes confidence. First time I ever gave a talk, man, I can't even tell you how fast my heart was beating, how anxious I was. I could probably speak in front of a group of God knows however many people you want me to talk to, and it's just like another thing because I do it so frequently now. So experience, confidence, all those things come with time. And just remember, you're the valuable asset. So you're going to take all those tools and you sell yourself, and that is the package that people are interested in. How can you take what you've learned and apply it to whatever career or whatever job or area that you're interested in? Do not lock yourself into a specific focused area. Don't say I can only work on breeding wheat because I've only bred wheat, right? There's bred wheat, huh? But just kind of follow me where I'm going there. Um, so let's move on here. So in terms of career opportunities, if you're working in head scab, you're getting all these great skills and tools. There's lots of different things. The two when I was in graduate school, it was like academic or government. That was really the big push. And yes, those are available. The opportunities are not as frequently encountered as in other things, but you can work in extension, you can be a faculty member, government like USDA, APHIS, those are going to be potential options for you. The other thing to keep in mind is you have things in industry, and there's a lot of needs out there in industry. And so if I would have just limited myself when I was back when I was younger and thinner and had more hair, I could have said, look, I just work on trees and mycorrhiza. And I would have just focused on maybe a faculty position somewhere, maybe doing ecology, or maybe I could have found a job in the tree industries, but I would have been very limited in terms of the people I'd meet, the experiences I've had, and the opportunities that I've had. Would have, right? But I'd be working in something that I'm familiar with, more or less. Really hard to get a job if that's the kind of focus that you have. Instead, I kind of took this other path and I said, well, I'm a broadly trained plant pathologist. I've got lots of coursework, lots of experiences. Yeah, I might have worked in trees, but I understand chemistry, I understand management, and all these different things. You piece them together, and that's how you're able to get a career maybe in somewhere else that you're not expecting, whether it's crop protection industry, working in the agricultural community. For me, vegetables and field crops, I would have never thought I was doing that. So do think about that. And with industry, there are tons of opportunities out there, and I will speak from myself and colleagues and friends that I have that are also in industry as well. Industry is really desperate for people that have broad skill sets, build the production systems, the needs of the growers. And so putting all those little things together really can make a nice career for you, in industry. And there are many different places. They're always hiring, and I would just say you should always consider this as another option. Okay, and there's so many different things you can do in industry as well. So that's my little soapbox talk about career opportunities and that sort of thing, and not limiting yourself. Now, I want to talk a little bit about wheat production and what actually happens on the countryside, because oftentimes when we're doing research, we're in the lab, maybe we're working with our samples, or we got pots going in a growth chamber or greenhouse, or we're using small plots out in the field and doing some sort of testing. That's not really what's going on with a grower. And when we're doing our research, we have to understand why we're doing our research, and then who the target audiences. And this is also going to be important as you kind of move forward with your careers and building your own career stories. Thing is, we have to keep in mind is farmers, they're business people, right? They need to be profitable. They don't grow crops for fun. They might enjoy it, but it is a business, and it's very serious. And so they are going to grow crops that are going to be a fit for them, for their production practices, their comfort level, and they're going to be growing them to make an income. So they typically, when we think about it, and I went around and I kind of surveyed some of our salespeople and other people that have been kind of in the business for a long time to kind of come up with these numbers. But you split up your growers into 3 different groups. You have your high input people. These are the individuals who are always striving for the best yield. They want to have top yield every year. They want to figure out what can give me more yield. What do I have to do? They're very progressive, willing to try out new things. So they're maybe a little more high risk when it comes to new things, but they're also the leaders. They represent about 35 to 40% of the growers out there. They're highly influential, and they're the ones that the majority of the other growers probably look up to, right? So if you think about sports or something like that, these would be kind of that top group of athletes in whatever sport you're thinking of. And then the next group we have would be kind of what I call the medium input growers. So these are people that it kind of varies on the operation, their experiences. They tend to have some flexibility in terms of changing practices, but they really oftentimes need a little more pushing, a little more motivation. They tend to be a little more averse to risk, but again, it depends on the individual, and that makes up about 30-35%. And then we have the last group, which makes up about a quarter of our folks, and that's going to be the low input people, right? So these are going to be the ones that are really cost conscious. These are going to be the ones that are probably going to have smaller acres. They're going to probably be a little more in tune with some of the apps and things. They're probably going to do more things on their own because they have smaller acres and that sort of thing. So when it comes to the work you're doing and how to actually get that information out there and influence people, you really have to be focusing on those upper 40% of growers, whether it's people at the USWBSI meetings or growers at other meetings. Those are the ones that really have the most sway. So when I was at Delaware, that was who I focused on in the Delaware, Maryland, Virginia region, but then also they utilize consultants, and one consultant can have dozens and dozens of growers. So if you influence that one consultant, you've successfully influenced a large quantity of your growers. So that's the people, those are the people that we really want to target with our research, because it has a trickle down effect. Those people below, especially if they're chatty or they're in newspapers or on the radio, those are the people that are going to be like, oh, okay, I'm going to influence these other individuals. They're looking up to me, and that's where you see the movement from that 35% of individuals in that medium group. And I think USWBSI has been very successful in this this influence, helping, especially when it comes to practices such as variety selection. We've seen a lot of movement in there. And then also there's been some widespread use, obviously, sides and figuring out the right timings. That's responsible. USWBSI has been partially responsible for that as well, and that's really helped reduce the impacts of Fusarium head scab. So what happens on the countryside? This is another thing that I think went back in my lab days before I really started interacting more with the growers. Is you have to realize that most of the decisions that are being made on a farm are being made before the season starts. Growers, the majority of growers, 75%, those medium to high level growers, are going to be making a decision months ahead of time. They want things planned out because they've got a lot of acres to go through, lots of things to keep track. They're contracting out their nitrogen, fertilizer, herbicide applications. They might be doing their planting themselves, but there's these other things that are being custom applied. And so they plan that out ahead of time. That means typically you don't just add on an application or quick change of variety last minute unless something happens, unless there's a shortage of a seed, or there's a replant that's needed or something along those lines. Okay, so everything's pretty much kind of carved out ahead of time. But in season, there are different ways that things are managed. And this is particularly important if you're somebody who's working on integrated management. We have our custom application, which I would say is the majority of the applications that go on are going to be custom applied. This means that you put in an order, or the salesperson, whoever it is that is the contact point for that grower, puts in an order to a custom applicator. It's usually it's either going to be a ground rig that unit owns. So in the case of GROWMARK, it might be an FS member. And I'll just throw a name out there. I'll say Southern FS, right? They have lots of different locations. So the grower will contact their crop specialist, and the crop specialist will put in an order to do the spray. Usually it's the crop specialist that controls all of that. And then it goes into a queue. And then it's kind of the order that you're in is when you get application. So you have to plan days ahead of time to make that application. So doing something in a day or 2 days notice isn't going to fly in the majority of situations. This is why scouting is important. This is why we say scout. Yeah, look for your diseases and insects, but also help staging. And I'll talk about that in a minute here. The custom applicators, airplanes are probably the most common. You do see helicopters in some areas, especially if it's very hilly ground, small fields, and then ground rigs also are fairly common out there. But if we talk about head scab, you think about when we do our fungicide applications at flowering, for example, if you've got head scab favorable conditions, it can be pretty hard to run a ground rig. And so you're going to be probably in an airplane anyway. And that means even those individuals that are self-applied, which sometimes are the big growers, maybe they own their own stuff, but usually it's the smaller folks that have those, they still might be calling in a custom application. And in my experience, the people that are doing their own and then they have to switch because the weather's so wet, they end up getting kind of the brunt of the bad luck, because they're probably the last in the queue, which means it might take them 10, 12, 15 days before they actually get their field, depending on the volume of calls that those applicators have and then the number of fields they have to get through. So in the field, sorry for that squeaky voice there. In the field, we have several different challenges that we encounter. And I think the biggest thing is going to be staging our wheat, because that staging wheat is going to be very important for fungicide timing, as well as rating and scoring our head scab. There's many things that look like head scab, and there's also going to be factors that come into play that can influence how we're rating our head scab, and some of the issues that can happen afterwards. So I'm going to kind of go through a little bit of this. So when we go and we take our classes, heck, you can go into your APS compendia, right? Go into your compendia. This will show up any, Purdue, Ohio State. Go to any of those websites and they'll pull out how to stage wheat. And they always show this, right? It's one plant. And well, we have to remember that wheat, it's like the grass we have in our yards, right? It's a plant that we plant it, and that single plant can tiller out, and those tillers can form additional heads, right? And so one plant can produce maybe 4 to 5 tops, little mini plants that can be more or less self-sustaining. And so we are managing a population that really the growing time differs depending on when that tillering happened, how extensive the tillering was, planting date. And then there's also going to be variability that occurs depending on soil temperature across the field, temperature type, nutrient levels, elevation and slope, because the sun might hit things differently, or maybe the air, you get some inversions and things are cooler or warmer. And wheat is very sensitive to that. And so when we're staging at the field, it becomes very problematic. And I'll go through some kind of tips on how I do that in a second. But when it comes to head scab, if you're doing research, small plot research, even pot research, there's a couple of things to keep in mind anytime you're outside, because we can't control the environment outside. No, there's a lot of uncertainty out there, as we all know. That this stage, the boot stage, Feeks 10, is really key. This is when the head is kind of moving up, almost reaching that point where it's going to break that last ligule there with the flag leaf and pop through. So once this stage occurs and we start having that flag leaf bend over, that's usually going to be a 10 to 14 day window before we're going to see flowering. So whenever I would run research plots, or even going out in the fields with growers or crop specialists, we're looking for those bent over leaves. And that's going to be typically what I'll use that as, that's an indicator, if you're custom applying, to start getting your orders in. Be at the front of those orders so that you're not waiting 15 days, because there's only a limited window to make an application if you're making one. But also if you're doing research where there's going to be some scoring of varieties or performance for head scab, understanding when flowering is going to occur is going to be critical. Because if you're too early or too late and you're traveling across a state or territory, and you can just imagine, like Tennessee, such a big east-west state, right? You could have some very inaccurate data, or data that don't make sense, because maybe your window was off, and you're too early or you're too late, and that's going to be really important. The reason that booting is important is because obviously with head scab, we're really interested in that heading, and specifically the flowering stage, which would be that Feeks 10-5 1 plus stage out there. So that's when these heads will start having those anthers that will pop out. They will start at that first main tiller, start at the center, and then usually they'll kind of bloom top to bottom there, right? And keep in mind, these are all plants at the same stage, but what do we have here? And this is kind of where the variability and confusion with head scab and control versus suppression comes in, because we are controlling a population of plants that are going to always be at different growth stages. You have your main tillers, which are here flowering, but you go further down, and I'm guessing these are maybe secondary or tertiary tillers here from the same plant. They might just be heading. They might even be at boot, depending on the variety and the temperature out there. The warmer the temperature, the closer those will be together, the faster things will go. The cooler, the more spread out things will be. Okay, so if you think about staging a field, you're going to notice that those primary tillers are going to go first, and it's going to oftentimes not occur across the field. It can occur in portions of the field. Usually the warmer portions are the ones that will go first, the ones that are getting a little more heat, maybe a little more light. That flowering across that section can occur depending on the temperature. If you're 80, 90 degrees, it could be several hours and it's done. And if it's windy, you might not even, you might have missed it, right? And so those anthers can fall off. If it rains, those anthers can fall off. And if you come back 4 or 5 days later, you might think you haven't even flowered yet, right? And you might actually have missed your kind of start time for that window. So you're going to have those primary tillers flower first, but then what ends up happening is those secondary and tertiary tillers are going to begin flowering at a later time. And depending on, again, the weather conditions and the variety, you're going to, that flowering can occur across that field for another 1 to 2 weeks. So you have the start of flowering, 10-5-1, and then you've got 7 to 14 days after. And when you look at the fungicide efficacy data, a lot of the data will say you can go 6 days, no problem. It's going to be just as efficacious. You're going to be hitting a lot of those secondary, tertiary tillers. In some conditions, you can even extend it further than that. And that a lot of that has to do with probably less risk earlier. And then later on, those secondary tillers are coming out and flowering. And if there's wet conditions or something like that, you're providing protections of those later on and allowing more protection through the grain fill period. So in terms of why we focus on the primary tillers, one, they're the starting, right? The starting gun, kind of letting us know when things are starting, but it's also going to be contributing 70-75% of our total yield from the primary tillers. The secondary, tertiary tillers only contribute about 30% of the yield, but I always argued the yield with head scab, it is important, but we can clean out pink kernels. We can clean out tombstones, right? We can do that pretty effectively. But when we get infection and vomitoxin elevation, that 30%, if they get infected, can be just as important as that beginning, 70% in the primary tillers. So that's the entire crop becomes important for managing head scab. That's why variety selection is so important. That's why we get suppression, not necessarily 100% control, because no matter when we apply a fungicide with one application, we are not going to be optimal for some part of that population in the field. Some are going to be a little past, some are going to be a little early, right? There's always going to be that spread. But when we're staging a field or you're staging plots, use that rule of thumb, 50% of the field, whatever stage that's at, that's the stage of the field. So risk for head scab when you're going out and you're trying to figure out what's our risk going to be like on the countryside. And this is something I deal with every year. I would say right now, from an Illinois perspective, you get into where the majority of acres are in Illinois and Missouri, probably pretty low risk this year. And I'm saying that from experience, but these are some of the things that I have learned that were taught to me, and I'm going to share with you, as well as some of the just kind of tips that I have that work really well for me. First, we have to realize that Fusarium head blight and the Fusarium pathogen or pathogens responsible for this disease, they do need to become active and kind of break dormancy before they're going to be able to produce the spores. And those spores have to be at a quantity that's sufficient enough to cause an actual level of severity that could result in elevated vomitoxin or yield loss, right? So typically this requires a lot of moisture. You want moisture about 10 to 14 days before that flowering starts. So if you've got sticky soils, if you're walking around in the soils from boot or before scouting and you're getting some of that soil sticking to the bottom of your boots, your risk is probably going to be elevated. Then if you've got temperatures that are warm, that's going to push it even more. It allows that fungus to grow faster, produce spores more quickly. But just because it's cool doesn't mean you're at low risk for head scab. A great example of that, oh man, it would have been 2013, 2014, someone in there. It was my first year at Delaware. And we probably had rain for 2 weeks straight, but if 58 to 62 was the top temperature, and we had some major head scab that year, and it was because of that persistent rain was kind of overriding that that epidemiology, you know, those factors that are really controlling the disease. So if you get enough moisture out there, you certainly can get disease. As long as it's above 60 degrees or so, you still can get head scab. Okay, so just keep that in mind. Also keep in mind that with our head blight, we have this is something that is a regional disease, right? And so we talk about residue management, things like that. Yeah, it can have a small impact, but about 70% of the spores that are infecting are being blasted up into that atmosphere, those ascospores. They're blowing around during the day, and when things settle at night, then they rain down on the plants. Okay, so there's always that regional inoculum. Those local spores that are being produced, the boat-shaped conidia, that's why I have that little boat in that picture there. The footballs for the ascospores. Those are going to be the ones that are predominantly kind of more, I'd say, shorter spread distance-wise, and they're also going to be more of the rain splash up the canopy type. So those are the ones where planting after corn or planting into high residue or after wheat or something like that, those are the ones that are going to be contributing more so in those cases. But again, just keep in mind, you can still get disease if that ground is sticky and you've got corn or any kind of grasses in the region. Those spores are moving 25, 50 miles in the atmosphere, and that's based on some work that Gary Bergstrom did back in the day. So what you want to do when you're assessing head scab, once you've figured out when your flowering has started, you want to make sure you put on your calendar, I want to be out there 18 days, especially if it's warmer, you want to be on that 18 days. If it's cool, getting out 21 to 24 days is probably going to be more optimum for you to get to rating. And that is because that allows the fungus to infect, cause symptoms and signs to develop. But at that point, your plant and that head are still going to be green, and they're not going to be senescing. Wheat senesces extremely fast, especially when it's hot out. And if you are a day or two late, you are going to miss the ball with rating. And then you get the pleasure, if you're a graduate student, you're probably going to do this anyway, but then you get the pleasure of doing Fusarium damaged kernel counts, which is just a blast, and you're going to love it, where you count out every little tombstone or discolored kernel in there. So if you can get, especially if you're breeding or something like that, if you can get these head scab ratings, it becomes very important. If you're helping growers out, this also is important for management. So this is how I do it in a field. I'll go in about one location, right? M pattern, just randomly out there, stay away from the edges, get a good representative sample. I say one location per 10 to 15 acres. That's how I scout, tell people to scout everything. At each location, you're going to just start walking. You got a bag in your hand. Your other hand, you're going to keep your head up, and you're just going to pick heads. You're going to pick 10 heads, put in the bag. Once you pick 10, move to another site. You do that until you go through all yours, right? Then you go back to your truck or your office, whatever. Then you're going to get your average number of spikelets per head. So you take 10 to 20 of those and just count how many spikelets there are. Turn it to the side so you can kind of see the V's. Those are how you're going to rate, and that's how you're going to count. It's easy that way. You just go down and up, right? You do it the other way, it becomes real messy. Then what you're going to do, that's going to give you the average spikelets per head, right? Then go through and you're going to count your just the number of bleached spikelets that you have on the head. So you just go through 1, 2, 3, right? And you're going to go through those, get those numbers and write them down. Then you do this simple math here. You take your total disease spikelets that you've counted for all those heads. You divide that by the number of heads you've assessed. That'll give you the average disease spikelets per head. And then you take that number and you're going to divide that by the average spikelets per head, right? Multiply that by 100, and that gives you an estimate of your overall head severity in that field. Okay, so keep that in mind. Turn it to the side so you can see counting. Very easy this way. It goes really fast once you've done this a couple of times. I will say though, on varieties are much harder to rate, but depending on the company, you know, Pioneer has a lot more naked varieties just because that's their breeding platform. But a lot of growers, boy, they like the on varieties. They oftentimes yield better, but deer do not like to eat on varieties. And if you're in an area where there are a lot of deer, which are most of us, right? We've got fields next to the edges of forests. Deer are major problems, and you will see this effect if you've got variety trials or anything like that. The deer will go after the naked ones. They'll eat those heads right off. Delicious, and oftentimes they completely avoid the on ones. So that's why we utilize on ones. But from a research standpoint, I personally hated them. They're scratchy, and they're hard to rate. But just keep that in mind as you're going through. How are we going to be using that information to give our individuals information in terms of making a decision, a management decision, right? So there's a fungicide management decision where you're helping with staging and you're helping them get their timing right and get that fungicide on at the right time. But then there's also the staging to figure out when you're flowering so that you know when to rate for head scab. Now you've got that information, and now what are you going to do with it? Okay, so head scab is a lot like ear molds in corn, the way I handle it. And so the way I kind of look at things is I look at my number. I've got percent severity. If my head scab severity for a field is greater than 10%, say 10 to 15%, right? That means there is some potential for elevated vomitoxin. It's not going to be very high. It's going to be there. There's some potential for reduced yields, but it's probably at max going to be maybe 2 to 3, 5%, right? Actual yield loss. So those are the fields where maybe you don't have to necessarily do something about it, but we should be having a conversation with the grower. The other thing to keep in mind is if you look at a head scab field from the side of the road and you're not actually assessing it like I showed you, you might say, holy smokes, this field is blasted, because it's so obvious, right? Head scab is so obvious, but you're not actually rating it. Once you get in there and you start rating the heads, you're like, oh, wait, it's only 5%. It's 2%. Looked like a lot more, right? So keep that in mind. If you start getting into the 15% plus severity range, that's when we're maybe getting a little more concerned that we're going to see a fairly significant yield hit, that our vomitoxin levels might really start to get into that dangerous level. Those are the people where, all right, now we got to start thinking about harvesting early. If we're harvesting and we're storing it, we got to dry that stuff down below 15%. A lot of people don't have a lot of on-site storage, at least if you're in an area where maybe wheat isn't the primary crop, right? Corn and beans are the primary crops. So a lot of that storage goes towards corn and beans, not necessarily wheat. But if you have adequate storage, hey, can you separate things out, right? A lot of people aren't going to do that, though. A lot of times you're going to have kind of self-blending, not on purpose, but they're going to mix in the good batches with the bad ones and then take that in to get sold. But the biggest things you can do in those cases is that early harvest, sell it, dry it down. If you have really, really severe head blight, talking about like I have greater than 15, I should have put 25%. That's when we start to think about, hey, we need to adjust our screens, our combine blower fan speeds, bump those up to try to blow out some of that chaff and some of that those tombstones that have really elevated levels of vomitoxin, because those are going to be really screwing you up at that point. And yeah, you might lose some yield in the field, but you're also going to be really reducing your vomitoxin at that point, improving your grain quality. So those are kind of the three different scenarios for head scab. Now I'm going to go into just kind of, that's a grainy image. We've all seen head scab, right? Maybe some of you haven't. But really what you're going to do, again, that 18 to 24 days after flowering, you're going to be looking for these bleached portions of the spikelets. And so when you look at these three spikelets, and I was talking about how you rate it, you should be able to see my pointer here. You see how I can see this is green and green and green, and then bleach, bleach, green, green, right? And this one here, I'd say probably bleach, green. I might call that a bleach, right? So that's going to make it so much easier when you turn them to the side and you just count that way. You do it this way, it's a mess. If you just try to rate the whole head at once, it might be a little faster. You're going to have a lot more variability. So that's why I do it. I've done it the way I do it, and I get really repeatable, reliable results that way. And they also tend to correlate well to the FDK numbers as well, more so this way. Now, if you got in too late, what's going to happen is you will not see this here. This whole head is going to become brown, and you're going to overestimate things. So that's why that you want to get in at just the right timing. What you'll also notice is that the base of the glooms here, the base of the spikelets, oftentimes you'll see an orangish to pink growth. That's going to be the Fusarium fungus growing there on that particular head. Okay, so that's a sign of the disease. Now, another one that is common out there and is a significant yield impactor, it can cause your grains to shrivel, maybe look like tombstones, but they're not going to be bleached. They probably aren't going to be pink. They're not going to be elevated in vomitoxin, is this Staganospora gloom blotch. This is a residue-borne one. It tends to creep up the plant because it's coming predominantly from that residue. Really likes it warm and wet. So those conditions that favor really heavy head scab also oftentimes are going to favor Staganospora gloom blotch. The fungicides we use to control head scab also control gloom blotch, same timings. Sometimes you will see this on the foliage as these kind of elliptical lesions with a little chlorosis on the outside. But more often than not, what you'll notice is that you can have it on the head and not on the leaves. You can have it on the leaves and not on the head, and that's because the resistance genes that control the resistance in the foliage versus the head are different. And so you can have one that's very resistant in the head and not in the foliage and vice versa. Okay, so this is why you might see this in a variety that may be rated good for heads for gloom blotch, right? Maybe they were rating the foliage and not the heads. Okay, so this one is going to be kind of purplish. You're going to notice that it will be on those glooms and it'll kind of move down. You will see sometimes the spore or the spore structures on the glooms as well with a hand lens. And the one thing here is the stem is not going to be affected. You're not going to see those pink orangish type spores on there. It just has that kind of grayish to purple look to it. Another one you might encounter, especially in bin run seed that isn't treated, is going to be loose smut. A lot of times you see this in our wild grasses quite often. Volunteer wheat. This is coming in on the seeds, and then just like our other smuts, it kind of comes in and it takes over the grains, right? And so you get these big powdery heads that are out there. They won't yield anything. Not something that's typically going to be yield limiting unless you've got somebody who just planted a bunch of bin run seed and wasn't treated, and the conditions were really perfect. So those are the situations where you see this one. That's where you have the conversation with the grower and you say, we either need to treat our seeds or we need to buy certified disease-free seed, right? And that's why we grow certified disease-free seed. Another one that's really frequent out there is black chaff. And this can look a lot like gloom blotch. You're not going to notice a yield hit. You're not going to notice the shriveling of the grain. You'll just notice that you kind of get this purpling on the glooms, but you also will see purpling on the awns and sometimes a discoloration at the base of that. I guess it would be the pedicel, right? So it's the base there of that head. This is kind of, it can be due to bacterial infections, although you will get folks that will say there's some fungi involved. Whether or not there are or not, it really doesn't matter because it doesn't cause yield losses. It's not head scab. You're not going to see the tombstones. You're not going to see the spores or anything like that, but it will occur again 18 to 24 days after. And then one of the most common things we see is sooty mold. So I like to say these are the fungi that are out there when you leave your bread open, a bag open on the counter, right? Or if you've got a nasty roommate and they leave food out or dishes out. There's the same sort of fungi. They're just kind of floating around, the sugar fungi. So all these are not impacting yield. Growers hate these things. They freak out when they see these, when they're combining. Oh my God, there's black stuff everywhere, right? Um, they're not impacting the yield. What it indicates is that your wheat was sitting out there for a long time in the field. What I tend to tell people is if you start seeing this in a field, you just need to be getting out there soon to harvest that, because if this is sitting out there much longer, you start to have falling number issues. And if there's more rain and drying periods. So if you start to see sooty mold, it means you need to harvest. Doesn't mean you're got any toxin issues or anything like that. So sometimes a fungicide will slow these down, but longer that wheat sits out there, the more that you're going to see. You can scrape this off real easy, kind of black, greenish color, very common. And then if you get up more into I'd say more into the Great Plains, like the Dakotas. This is where you're going to find more ergot. We typically don't see a lot of this, again, unless we've got a lot of wild populations, volunteers out there, untreated bin run seed. This is just one of those things that we don't see a lot of in most areas, unless you're in those Dakotas, maybe Kansas out there, serious wheat production, barley production areas. Don't get me wrong, obviously, but just in general across the United States and Canada, we don't see a lot of ergot. And then the last thing to keep in mind is freeze damage. And so wheat, for the most part, handles freezing temperatures very well, especially winter wheat. It actually needs that cold temperature to cause it to get into that reproductive growth and start producing heads, right? The further along in growth we get, the less resistant wheat becomes to freezing temperatures. And so if you have wheat that is exposed, if those heads are at the boot or they're breaking that ligule, they only need a couple of hours under 28 degrees to start to see freeze damage. And the freeze damage you'll see as distorted heads, but oftentimes what you'll see is bleached heads or portions of bleached heads. They might also have Fusarium on them because it's dead tissue and it's wet weather, and Fusarium are saprophytes, right? Or necrotrophs, however you want to categorize, depending on the species. So it might look like head scab, but it's not. You're going to notice patches of this in areas typically, or it's going to be just certain heads that have it. The primary tillers are a certain stage of the plant that are infected. Usually you will notice the exposed portion is going to be what's infected, what's affected, I should say, versus unexposed. And then you're also going to look through your weather and you're going to say, well, we had a frost event, a couple days ago. Usually these symptoms show up about 3 to 5 days after a frost event. Okay. But they can get confused as head scab. So just keep that in mind. This is where the weather is going to be really, really important. Sometimes you will get things that kind of overlap, but by and large, if it's frost damage, you're going to see half a head, full head. You're not just going to see those individual spikelets, and you're not going to see tombstones. You're more likely to just see complete blanks at this point where it aborts, depending on what's exposed. So with that, I think that's what I have for time, and I will open it up if anyone has any questions. And I had my information on my first slide. Feel free to contact me if there's ever anything you want to ask about related to field crops, plant pathology, Green Bay Packers or Seinfeld or Simpsons. Feel free to shoot me a message. So.
Well, thank you, Nathan, for that great presentation. If you guys have any questions, you can either turn on your cameras and your audio and ask Nathan directly, or if you choose, you can also put them in the chat.
Hey, thank you, Nathan, for such a great presentation. It's Bhavit this side. Can you hear me?
Yeah, I can hear you. Yep.
Hey, I have a question about fungicide resistance.
Mm-hmm.
So after after scouting or after how much fungicide resistance are you seeing in fields based on your experience of different fungicides that are in the market, like trizoles or any SDHIs?
Yeah, I mean, there's some reports of some insensitivity out there, but by and large, anything significant where someone makes an application and it fails has not really been a concern. A lot of the new fungicides that are out in the past, it was all triazole based. Triazoles in general are the ones that are a little harder to develop resistance to, and we can kind of adjust. But now with our second generation SDHI molecules, those are getting put in some of these newer products out there, and with 2 different modes of action that will further reduce the likelihood for seeing any significant resistance issues. But it is, it's a concern. You get out into Europe, I think they probably have some more instances, but again, they
Okay.
don't see just complete failure out there like we see in some of our vegetable crops and some of
Yeah.
our downy mildew fungicides and things like that.
Thank you.
Yep.
And I have another question about barley scoring, actually.
Sure. Yeah.
So if you have any insights on that, because I remember we having a very hard time scoring barley, and also looking at the flowering time because it flowers inside the boot and stuff. So if you have any insights for us and other students to when we went to score barley, what conditions or what things we should keep in mind
Yeah,
for
and you're right.
scoring that.
So barley, sometimes the anthers will pop out and you'll think you're looking at flowering, and it can vary by variety, temperature, all sorts of different things. Really, what you're targeting there is that those heads clearing the ligule. So if those primary heads have cleared the ligule about 50%, that typically is equivalent to the start of the flowering period. That's kind of what I use as a judge to start the clock, just because
Okay.
you can't necessarily see it. And then of course it'll pop out later, and then you can start scoring it. But that's what I would use a similar type of score where you're going in and you're just looking at clearing that ligule of the flag leaf, 50% cleared or more, and then that's going to kind of give you the start of that clock where you need to start thinking about, all right, 18 to 24 days from now, I need to be out here scoring.
And do you like any do anything different for 6-rod versus 2-rod barley, or is it like, so for 6-rod, if one floret is infected of that, you call it 1 or like call it 3? So do you have any insights on that?
So I never had to deal with, which one was I working with? I can't even remember. I only worked with one of those
Okay.
out on the East Coast. And I'm trying to remember
Violeta?
Violetta would have been one of them. So is that a 6
Yeah.
or a 4? Oh,
It's 2-row.
it's a
Violeta
2.
is 2-row.
Yeah, so those are
Yeah.
the easier ones, right?
4-row
So
bread is 6-row.
yeah, so
Yeah.
I didn't have the fortune of having to deal with that frustration. So I wouldn't be able to
Yeah.
provide much insight there.
No worries. Thank you so much for such a great talk. Yeah.
Did someone send a message?
Yeah, there's a message in the chat, Nathan.
New fungicide chemistries, active ingredients. Yeah. So the answer to that is yeah. But everything at this point, I try to tell people, and it's like this with all of our field crop fungicides. I don't know if anyone here drinks energy drinks, right? You go into the cabinet and there's all these different names of energy drinks, but when you look at the back, it's all kind of the same stuff. That's kind of how we're at with our fungicides for head scab. They're all going to be relatively similar in terms of they're going to be a triazole or an SDHI. There might be a newer active that may have some different characteristics, may have some different price points. But in general, the overall control we're getting isn't going to be just huge leaps and bounds different. It's going to be maybe small ratcheting up the ladder. So we make improvements, but they're not going to be huge groundbreaking improvements. So yeah, you will see things coming out in 5 years or so, different chemistries, but nothing that I'm aware of that is just going to light the scab world on fire. But we'll give more tools, which is great. Having more tools is really what we need.
But on that aspect, do you have any like insights on any biological product
Yeah,
that
so
is
so people have been trying to work with biologicals, and I think the way we are thinking about biologicals now is different than the way they were thinking about them previously. So what I think you're going to start seeing, and you've started to see some of this already with some products, is, and there's this product called Ethos XB, and it's an insecticide and a biological. You're going to probably start seeing fungicides that contain a biological as part of the premix. And you're not going to necessarily see a standalone. The other thing you're probably going to see is that the biological may not necessarily be a biological control. It might be a biostimulant or something else that will help yield and not necessarily and improve things, but not necessarily prevent infection by head scab. But there's a lot of, that's obviously a focal area. I just think the way we need to think about biologicals has to be different than the way we were thinking about it 10, 15 years ago.
Thank you.
Mhm. Any other questions? Those are really good questions. It's always nice to have good interaction. So.
Well, if there's no more questions, we'll thank Nathan for providing his time and giving a great webinar. And if you guys would like to re-watch this or share it with your colleagues, we'll be sure to post it on our YouTube channel and the GP for FHB webpage in the next coming weeks. So thanks, Nathan.
Yep. Thank you for the invitation. Thank you, everybody. Have a great day and great weekend.
Thank you.